Beep, bop, boop, bop, beep, bop, 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 bop. Grrr. Expanding. So we're going back, briefly, we're going to go back to high school. X and Y are real numbers, not vectors, just real numbers. What happens when you expand x plus y times x plus y? How do you do that? Well, if you went to high school in English, you may have learned something called FOIL. I believe that's still taught. Anyways, doesn't matter. Forget about it. Let's not do that. Let's do distribution. And you'll see why in a moment when I'm insisting on this. So distribution, I'm going to do this guy. I'm going to multiply it to the x and also to the y. So I get x plus y, x plus x plus y, y. So this product here, so this is all real numbers. No dot product, no cross product, nothing funny. We're just remembering what distribution is. Okay, then you do the distribution the other way. Okay, this x is going in there and there. And likewise with the y here. What do you get? You get x squared plus yx plus xy plus y squared. When we're talking about real numbers, these products are the same, right? So we get x squared plus 2xy plus y squared. Okay, the main thing I want you to remember is the distribution here, because we're going to do this type of expansion in a different land, a different neighborhood. Let's consider x, x, y in R, whatever, Rn. Now if I'm doing a dot product of x plus y dot x plus y, okay, do I still get something resembling this? I don't get exactly this, but I do get something resembling it. Look at x and y, it's different here. X and y are vectors in Rn. I have a dot product here. So I still have this distribution idea. Okay, distribution still works in the land of dot products. Don't forget your dots. Gotta have those dots in there. You know, if you write something down like x, just xy, you know, if you write that down, you're going to see me do this. Question mark. What is that? I don't know what that is. I've never seen such a thing. It does not exist in my neighborhood. In my neighborhood, we have a dot product or a cross product, not a absent product. Don't forget your dots. What do I get here? So I did distribution. Same idea I did here. Okay, and I can do it again. Okay, don't write, also don't write. Okay, that's meaningless as well. If you do, I don't know what that is. So what I have to do is I have to do x dot x. X dot x plus y dot x plus x dot y plus y dot y. Now, another property of dot product is that these things are the same. these things are the same. And what else? The dot product of x with itself is the length of x squared. Okay, so x dot x can and should be replaced with this. The two x dot y terms can be combined in this case, because we do know that x dot y is equal to y dot x. That is true for the dot product. And then finally we have the y dot y. Giving us this. Okay, so we do have something. In the end, we do have something that resembles what happened in the high school case. Cross product. What about cross product? So now we'll be in R3. And what will we see in R3? Come along with me. We'll climb a tree. The tree of knowledge. Now if we have x and y in R3, okay, you'll recall that cross product is defined in R3. I think there's some version of it that's defined in R7, oddly enough, but in between there's nothing resembling a cross product as we know it. Let's do this expansion. Cross. So what's that going to be? What's that going to be? Well, remember if you have a vector cross itself, we have a property that says this is the zero vector. So if I have a vector cross itself, I'm expecting to get the zero vector at the end. Let's see how that happens. So I'll write that down. So expecting equal zero vector. Well, it is equal to zero vector, and we can conclude that just from using our property, but that's no fun. Let's calculate. So I want to calculate carefully using distribution, just to show you how distribution can show us something, some inner workings here. So I'm going to do the same distribution I did here and also here, the same form. And now I'll do another distribution. Okay, notice, you know, you're going to be tempted to subconsciously switch these. Okay, remember, for the cross product, can't do that. In fact, U cross V is equal to negative of V cross U. Okay, that is the thing that is true. Okay, do this distribution here. We got X cross Y plus Y cross Y. Now, how does this end up being zero? Well, I'm just going to use my thought cloud here. Okay, because of the first bit here, this is 0 plus y cross x. I can change the order here. If I want to try to put these two terms together, I should change the order of one of them. I'll do the other one. I'll do the second one. And y cross y is 0, again, because of this property. And there you have it. I do get the 0 that I was expecting. Okay, what's the moral of the story? When you're doing expansions of binomials, you want to do, at least here and here, you want to do a careful use of distribution.